compiler flag selection plugin of the Periscope Tuning Framework can be used for tuning the single core performance of an application by selecting the best combination of compiler flags. This video gives an overview of how to use the CFS plugin. This plugin automates the manual tuning process done by experts to facilitate code tuning for application developers. It releases the application developer from studying the compiler documentation to find potential flags and to do all the experiments to determine the best combination. The flags that are to be explored can be defined by the programmer, but can also be read from a default configuration file for the used compiler. A large number of flags can be efficiently explored with advanced search algorithms. The plugin is easy to use and provides special support for large applications consisting of many individual files. Now we show you how to tune the BT multizone benchmark of the NASA Parallel Benchmark Suite. It is a Fortran 90 application and is compiled with the Intel Fortran compiler. Here we logged in to the supercomputer at the Leibniz Supercomputing Center in Garching. This is a configuration file for the CFS plugin. The default file name is cfsconfig.cfg. The CFS plugin comes with templates for several compilers used in the HPC domain. These templates specify the most important compiler flags. To use the default settings, you specify the compiler used for the application. Here it is the Intel iFort. The CFS plugin recompiles the application with a selected flags combination and then runs it to measure the execution time. To recompile the application, it first touches the source files and then issues a make command. The path to the source files as well as to the make file must be given in the configuration file if these files are not in the directory where PTF was started. In addition, the environment variable is specified that is used to pass a flag combination to the compiler call in the make file. As well, the parameters required by the make file to determine the benchmark, the problem size, and the number of MPI processes are given. This is a template configuration file for the Intel Fortran compiler. The most important compiler flags are specified here, as well as a search algorithm. Instead of importing the template file via the compiler definition in the configuration file, these specifications can be copied to the application-specific configuration file and adapted for the application. The makefile of the application needs to be adapted so that the CFS flags environment variable is used during compilation. This is performed here. The CFS plugin can work with uninstrumented and instrumented applications. To instrument BTMZ, the compiler call is prepended with the PSC instrument call. The details of instrumentation are explained in another video. Instrumentation is advantageous since the time measurement is done inside of the application for the main program, and thus overheads for starting the application are not taken into account. Issuing the make command will now prepare the application for tuning. All the application source files are first pre-processed, then instrumented and compiled. At the end, the so-called ZIR files containing static program information generated by the instrumenter are merged. After the preparations, the batch job can be submitted. On SuperMUC, it requires a load leveler script that starts the Periscope frontend with some command line parameters. First, the application is given with a ZIR file, the number of processes and threads. We select also the plugin to be executed by the --tune argument. Now the batch job is submitted to the batch queuing system. It immediately starts executing. We now have a look at the output of the tuning job. The execution starts with reading the configuration file. The specified search algorithm, the default is individual search, is loaded and initialized with the specified flags as tuning parameters. The search algorithm creates the different tuning scenarios specifying the flags combinations. For each scenario, the application is now recompiled and the execution time is measured. When the plugin terminates, it outputs the best scenario and the execution time for all scenarios. This information is printed to standard out and written into the advice file in XML format. For BTMZ, the plugin found that the best combination is scenario 4 with O3, Xhost and unroll. The CFS plugin is thus easy to use and explores the compiler flags automatically. It provides a number of advanced features that help you to reduce the search time and to influence the breadth of the search. These features are presented in other CFS plugin videos. Thank you.